Alright guys, now we'll start with the basics of linear equations. In the first module in this chapter, we already saw the general form of the linear equation, which was ax plus by plus c equal to 0. What is a linear equation in two variables? It is equation of a straight line. Now if there are two linear equations that I give you, so how will you denote them, or how will you separate them? For the first one, we'll write it as a1, b1, c1. For the second one, we'll write a2, b2, c2. A and b are the coefficients of x and y, and c is the constant. Now, in the previous four modules that you saw, we were learning how to solve a pair of linear equations. And in every pair we got one answer, which means the pair had one intersecting point, which means it had one common solutions. But there are other possibilities as well. There might be two pairs of linear equations which do not have any solution, or they might have infinite solutions, which means they are the same line. So what are the three possibilities? One is one solution, right? Or unique solution. This is what we learned in the previous module, where there is only one solution. It is also possible that there are no solutions. I'll tell you how. And there is also a possibility that they have infinite solutions. Right? Now, for a unique solution, if I just give you two equations and I tell you to check whether they have unique solution or no solutions or infinite solutions, you don't actually have to sit and solve the pair of linear equations. You can just use a1, b1, c1, a2, b2, c2 and check. In case a pair of linear equation has only one solution, you will find that a1 by a2 not equal to b1 by b2. So this by this will not be equal to this by this. In case of no solutions, what you will get is a1 by a2 equal to b1 by b2, but not equal to c1 by c2. So this by this will be equal to this by this, but it will not be equal to this by this, which means there are no solutions. For infinite solutions, very easy, I guess you can already guess it. a1 by a2 equal to b1 by b2 equal to c1 by c2, or these are overlapping lines. So generally when there is unique solution, when you plot a graph, you will get two lines which intersect, like in the previous modules. No solutions, in which case will two lines have no solutions? When the lines are parallel, because they never meet, right? So they don't have even a single coordinate which is common. It means it has no solutions. So that is for a pair of parallel lines. And infinite solutions is nothing but you get two different equations for this. It's the same line actually. The lines are overlapping, but they are written in a different way using different A, B and C. But they are the same line. So they are overlapping lines. So in that case, it will have infinite solution, because since they are overlapping, every point is a common point. So guys, remember this. It's also available in the downloads, formula downloads. You just have to remember the condition for unique one solution, a1 by a2 not equal to b1 by b2. You don't have to bother about c1 and c2. For no solutions, a1 by a2 will be equal to this b1 by b2, but it will not be equal to c1 by c2. And for infinite solutions, all three will be equal. So guys, remember this. Now there is another name. When a pair of linear equations has one or unique solution or one solution, it is called consistent. If it does not have any solutions, it's called inconsistent. And if it has infinite, it is called dependent consistent. You just have to remember this, because the question might be worded. They might either ask you, check whether the given pair of linear equations have consistent solution, which means you need to remember that consistent means one solution. You have to check whether it is one solution. If they ask you if the given pair of linear equations are dependent, it means they are asking you whether it has infinite solution. So you have to check this condition. And if they tell you check whether it's inconsistent, it means they are talking about a pair of linear equations which have no common point, which means no solutions. So you have to check for this. Alright guys, we'll solve one question now. They have given us a pair of linear equations, and the question is, for what value of A and B will this have infinite solutions? So they have told us this has infinite solutions. We have to find the values of A and B. Now if we have to find values of A and B, we need two equations because two unknowns. How do we find it? Remember the condition for infinite solutions. What is it? A1 by A2 equal to B1 by B2 equal to C1 by C2. So using this condition, we can find the values of A and B. We can form two formulas. So A1 by A2 is 2 by A minus B. This will be equal to B1 by B2, that is 3 by A plus B, which is equal to, okay, now C1 by C2. Is 7 and this C1 and C2? No. Remember, whenever you are using these conditions, the pair of linear equation have to be in general form, which means I have to transpose C on the left hand side, which means this will become minus 7 equal to 0 and this will become minus of this equal to 0. Right? Actually, it doesn't matter, but when you are writing it, write it like that. You may lose marks because in the end, when I do minus 7 by minus 3A plus B minus 2, minus and minus will cancel. But it's still you need to show it. It is better. It's good practice. Alright. Now we substituted the values. Now we'll use the first two. A1 by A2 equal to B1 by B2 to form the first equation. So what do we have? 2 by A minus B equal to 3 by A plus B. From here, I'll transpose on both sides. I'll get 2 into A plus B. So 2A plus 2B equal to 3A minus 3B. Right? Now I'll transpose A terms on one side, B terms on other side. So I'll bring minus 3B here. It becomes 3B plus 2B equal to 3A minus 2A. So I get 5B equal to A. We got one equation, right? Like we got one equality. Actually, I can solve this as a pair of linear equations as well. I can write this as A minus 5B equal to 0 and then form another linear equation here and solve using elimination or substitution method. But here directly we are getting A as 5B, so we'll use substitution method. It will be very easy. So now using this 3 by A plus B equal to 7 by 3A plus B minus 2. I transpose, I get 3 into this. So it becomes 9A plus 3B minus 6 when I multiply 3 by the whole equation equal to 7A plus 7B. Now I'll transpose 7A this side, it becomes 9A minus 7A, and I'll transpose minus 6 and I transpose 3B that side, I get 7B minus 3B. So I get 2A minus 6 equal to 4B. But how much is A? 5B, right? So 2 into 5B, I substituted, minus 6 equal to 4B. So I get 10B minus 6 equal to 4B. And now I transpose, what will I get? 10B minus 4B equal to plus 6. Signs will change when I transpose. So I get 6B equal to 6. So B is equal to 6 by 6, which is 1. Now I got the value of B. Here substituting this, I'll get value of A as 5. Why? Because B is 1, 5 into B, 1 is 5. So I found the values of A and B. Right guys, the second problem we'll solve in this module. Now they've given us pair of linear equations and the question is find the value of K if this pair has no solutions. So it has no solutions, right? They have told us this has no solutions. So for no solutions, what is the condition? A1 by A2 equal to B1 by B2 not equal to C1 by C2. To find the value of K, we can use any of this. So we'll use this. Okay. So A1 by A2, that is K by 6. Before that, we need to transpose. So this 2 will become minus and this becomes equal to 0. So K by 6 equal to, remember B1 is minus 5. Don't forget to take the signs. So minus 5 by 2, right? We got this So we can transpose. Okay, this will not be equal to minus 2 by minus 7. Minus minus cancels. Okay, so using this, k by 6 equal to minus 5 by 2. What do I get? K equal to minus 5 into 6 by 2. So 3. So k equal to minus 15. We got value of k. We'll verify over here. So we'll take the first and the last one. So what do we have? K by 6 not equal to 2 by 7. So k is not equal to 2 by 7 into 6. So k not equal to 12 by 7. So since k is minus 15, it is not equal to 12 by 7, which means the value of k is minus 15. Alright guys, I hope by now you have understood how to use the no solution conditions for infinite solutions, unique solution and no solutions. So generally those are the kind of problems you will face in exams. Now what we'll do is, now in the previous modules we had learned how to find solutions for pair of linear equations using different methods. Now we'll now learn a few special kind of equations that you might get. For example, this, if they ask you to solve this pair of linear equation, it is a pair of linear equation, no doubt. So how will you solve this? Whenever you have something like xy on the right hand side, don't bother cancelling it. Just open the brackets first. So 3 into x, 3x plus 9y equal to 11xy. Now this becomes 6x plus 3y equal to 7xy. Now in this kind of problem, this is why I like elimination method, because if you are planning to use substitution or cross multiplication method, it becomes very complicated to solve this kind of problems. So we will be using elimination method to solve these problems. Go solve it exactly like how we had solved this problem before, Now we have to make one of them equal. So which will I make it equal? I have 6x here, 3x here, which means I only have to multiply the first equation. So I'll make the values of x equal. Here I need to multiply the whole equation by 2. So 2 into 3, 6x plus 18y equal to 22xy. Here we do not have to multiply anything. So 6x plus 3y equal to 7xy. Now both are positive, so I'll subtract the two equations. When I subtract, the signs will change. So 6x minus 6x, 0. 18 minus 3, 15y equal to 15xy. Now what happens? This y and this y cancels. Why? When I take y on the other side, it becomes by y. Y by y will cancel. So and 15 and 15 cancel as well. So what do I get? X equal to 1. Remember, it's not 0. It becomes 15 by 15, 1. So I found the value of x. Now substituting in one of these equations, I'll find the value of y. I'll take the first equation. X is 1. So 3x becomes 3 plus 9y equal to 11y, because x is 1. Right? So I transpose this. I get 3 equal to 11y minus 9y. That is 2y. So y equal to 3 by 2. So I got the value of y as 3 by 2. So you can check by substituting in any of these equations whether the answer is correct. Alright guys, this is another kind of problem that you might face in exams. 4 by x 5 plus 5 by y equal to 3, 6 by x minus 15 by y equal to 0, where x and y are in denominator. Now there are two ways. Generally most people, how they solve is, what they'll do is, see, it is of the form, when you say 4 by x, it is of the form 4 into 1 by x plus 5 into 1 by y equal to 3, and this becomes 6 into 1 by x plus minus 15 into 1 by y equal to 0. So what they do is, we'll take 1 by x equal to u and 1 by y equal to v. U, v, m, n, anything you want, you can take them as. So when I take 1 by x as u, what happens? Here I get 4u, right? Plus 5y, 5v. And here I get 6u, right? And here I get minus 15v. equal to 3 and 0 over here. Right? So we have taken 1 by x as u and 1 by y as v, and we have gotten this. Now it is like a normal form of linear equation. Now I'll again use elimination method because that is my favorite method. Guys, if when you are giving tests or anything, unless it is mentioned, you use whichever method you find easy. Alright, but I prefer elimination method because it is easy. Now I'll cancel u, 4 and 6. What is the LCM of 4 and 6? 12, right? So here I have to multiply by 3, here I have to multiply by 2. So I get 12u plus 15v equal to 9, and I get 12u minus 30v equal to 0. Now both are same, I'll subtract, so signs will change. This cancels, 15 plus 30, 45v equal to 9. So v equal to 9 by 45. Right? So 9 by 45, 1 by 5. So what do we get? V equal to 1 by 5. Now we'll find the value of u itself before we find the value of x and y. So I'll substitute in one of these equations. I'll take the first equation. So it is 4u plus 5v, that is plus 5 into 1 by 5 equal to 3. This first equation I have taken. Alright. So 5 and 5 cancels, I get 4u equal to 3 minus plus 1 becomes minus 1. So 3 minus 1, 2. So I get u is equal to 2 by 4, and I get u equal to 1 by 2. 1s are 2s are. So I got u equal to 1 by 2. Now what do I do? But u is 1 by x. So 1 by 2 equal to 1 by x. From here I get it, right? So I transpose, I get x equal to 2. And using the second, we have v equal to 1 by 5. So from using this, I get 1 by y equal to 1 by 5 from here. Right? So transposing, I get y equal to 5. So this is the simplest method that you can use to solve this kind of equation. Alright guys, now we come to the end of this module. Now there are 2 tests after this which you need to give. I hope you have understood how to use the conditions for no solution, unique solution and infinite solution. What do they mean? And how to solve a pair of linear equations by all 4 methods. So good luck for your next 2 tests. Don't worry about how much you are going to score. Just try them, and there are video solutions available for both of them. So by the time you reach the main test at the end, I'm sure that your linear equations will be very good.